Chapter 3, Day 2 notes. We're talking about solving equations. These are actually skills that you already have. We're just going to look at a few different problems that maybe you haven't seen before. So the first example, I'm just going to give you 4v cubed minus 12v squared minus 5v plus 15. Now what we've done before is we can factor this stuff. We can do factor by grouping. So right now this is an expression. So the big difference for you, right now there's nothing to solve because there's no equal sign. But if my directions say solve, that means there's an equal sign and this thing is going to be equal to 0. So now we actually have something to solve for. So we should get an answer in the end that says like v equals some number. Before we just factored the thing and we were done. But now we're going to get answers for v. Okay, so the best way to do this, since we have to do it by hand, is since there's 4 terms, let's do factor by grouping. So let's group up the first 2, group up the last 2, and then what can I take out of this first pair here? It looks like the biggest thing is 4v squared. So if I group up those first 2 terms there, 4v squared is what I can take out. And I think we're left with just a v from this guy, and then a minus 3 from this guy. And then from the back 2 terms here, you can take out a negative 5. I mean, you could take out a positive 5, but then we won't get a match when we're done. So let's take out a negative 5 from those, and then we'll get v minus 3 here too, and that's key. We want those to match up there in parentheses. Okay, so now that we did the factor by grouping, we have a match. That's key. V minus 3, v minus 3. It's kind of like we factor those v minus 3 terms out, and then we're left with 4v squared minus 5. So v minus 3, and then what's left over? 4v squared minus 5. And this is all still equal to 0. So we just did factor by grouping. So we're halfway there. Now to solve, how do we solve this? So it's equal to 0. Let me remind you of a little something called the zero product property. The zero product property, aka the ZPP, which says this. If you multiply 2 things together and get 0, well, there's only 2 times that can happen. Either the x was 0 or the y was 0. So that's what this property says. Multiply 2 things to get 0. One of them had to be 0. So we're going to check both. We're going to get answers for when either one of these terms is 0. So that's our next order of business, is set each term equal to 0 and solve. Shouldn't be too bad. So v minus 3 equals 0, and then the 4v squared minus 5 equals 0. So this one's really easy on the left here. Just add 3 to both sides. V equals 3. That's one of our answers. This one on the right, first thing we need to do is take care of the easy stuff. So add 5 to both sides. First thing is add 5. Then divide everything by 4. Get rid of that 4. So we get the v squared by itself. Last but not least, you have v squared equals 5/4. Well, I'm not interested in v squared. I want v. So how do I get rid of the square? I take the square root of both sides. But don't forget, when you take the square root of a variable, that's when you have to put plus minus. So I take the square root of both sides. So my answer for v here is plus minus the square root of 5/4. And I'm just going to leave it that way. I'm not going to go get a weird decimal in my calculator. So factor by grouping, set each term equal to 0, and then solve each term. Alright, example 2. The directions just say solve. I'm going to give you this nasty looking equation. So 2 over z minus 3, and then 7 over z squared minus 3z. Okay, I guess you could try to get common denominators and add these 2 fractions together. It was actually easier than that, though. So we can clear out these denominators. We can get rid of these fractions in one step if you pick the right thing to multiply through by. And in doing that, let's look at this z squared minus 3z. Doesn't that factor? Couldn't you take a z out of that? So if you take a z out of that, that's really just z minus 3. Which is also, I mean, that's a z minus 3, right? So the least common denominator between these two, if we multiplied everything through by z minus 3, that would clear out everything in this denominator and everything in this denominator. So that's going to be the first order of business, is multiply by the LCD, the least common denominator, on both sides, which in this case is just z minus 3. Or if you want to say z squared minus 3z, sure, go ahead, but that's the factored form. So if we multiply that through on both sides, it will clear out those denominators. So let's do that. So z minus 3, and then z minus 3, which that'll just go to 0. So if we distribute that z minus 3 through there. So on the right hand side, that was easy. 0 multiplied by anything is 0. On the left hand side, 2z minus 3, 7z minus 3. So now let's just cancel these things out. So z minus 3, that's gone. That's the whole point. And the z's and z minus 3's are gone here too. So now it gets a lot easier. So we picked the right thing to multiply by on the first step. Things get a lot easier. So we cleared out the denominators. And we're just left with 2z plus 7 equals 0. Well, now that's pretty easy. Subtract 7, divide by 2. Z is negative 7 over 2. So I just wanted to show you one like this, just to remind you, if you have weird denominators, you pick the right thing to multiply by in the first step, and you can clear out those denominators and make things a lot easier to solve. Alright, example 3. Solve the system. We're going to look at a system of equations by hand. The other way you could do it is you graph on your calculator, but we're going to solve it by hand. So here's the system. Two equations. Y equals 2x squared minus 7, y equals x plus 3. Okay, so you learn a couple methods to solve these back in Algebra 2 and Algebra 1 even, like substitution or elimination. Like if you subtract these equations straight down, the y's would cancel out, and you would just have some x's left over. That's one way you could solve it. Or if we do substitution, we can just set these equations equal to each other. Like y equals this, y equals this. So we could just say 2x squared minus 7 equals x plus 3. We could solve it that way. So I'm gonna look at that. I want to go that route with substitution. So we're going to set the equations equal to each other. So instead of y equals, we'll say x plus 3 equals 2x squared minus 7. So basically I just substituted that in for the y. So set the two equations equal and then solve. Well, since this is a quadratic, it's got a square. We got to get everything to one side and 0 on the other side. So if I can subtract the x over, subtract the 3 over, I get 2x squared minus 8x minus 10 equals 0. So that equals 0 piece is key for us to get answers. The only thing is, I don't think this one factors. 2x squared, that doesn't factor. But that's okay. And by hand, we still have to get an answer. We still can. For things that don't factor, we have to use the quadratic formula. So this is not factorable. It means we're going to get our answers using the quadratic formula. Okay, so hopefully you didn't forget the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And this does simplify. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. There you go. Don't ever forget it. So really, what's in that square root there? 8 plus or minus square root of 88 over 4. Okay, square root of 88 is a perfect square that definitely goes in there. And that perfect square is 4. So 4 goes in there 22 times. So if you think about square root of 88 as being 4 times 22, well then you can just take the square root of that perfect square. So really we can just call that 2 root 22. So let's do that. 8 plus or minus 2 root 22. So square root of 88 actually simplifies all the way down to 2 root 22. And now, before we couldn't cancel. I know you want to cancel these even numbers. Don't do it. Now you can cancel because you've got an 8 and then a 2 on this term and then a 4. So now every term actually has an even number in it. Before, you couldn't touch anything in the square root, so you can't cancel anything in this step. But now you can cancel a 2 out of everything. So we cancel a 2 out of each one of those terms. So we get a 4 plus or minus the root 22, because that 2 canceled out. And everything's over 2, because the 2 canceled out of the 4 twice. Okay, and then the last thing I want to add that's going to help us get our solutions when we're done is I want to split this fraction up right down the middle. So if I could split this fraction up right down the middle and call this 4 over 2 and then root 22 over 2. So 4 over 2 plus or minus root 22 over 2. And the reason I do that is because 4 over 2, that's an easy number. So for our solutions, for our x values here, you can really just say this is 2 plus or minus root 22 over 2. Okay, why did I go through the trouble of doing that? Well, this is a system of equations. So we just got answers for x, but what are the answers for y? So if you do this, once you get the x answers, these are the x answers, we want to know what's the y, what are the y values. Just take this answer and substitute it back into one of these equations. I'm going to pick the easier one. It really doesn't matter which one you pick, but I'm going to pick the easier one here. So what are our answers for y? Okay, well, if y is just x plus 3, I'm going to take this answer for x and put it in there in this equation. So x plus 3, and notice I left it blank. X plus 3. And put this 2 plus or minus root 22 over 2. Put that in there. And then this is actually pretty simple. Just combine like terms, so the 2 and the 3 are like terms. So this is really just 5 plus or minus root 22 over 2. And those are our answers for y. Okay, so our solution, x and y, let's write them as a coordinate pair. So up here, our solution. So as a coordinate pair, xy. The x's, 2 plus or minus root 22 over 2. The y's, 5 plus or minus root 22 over 2. So that's just like coordinate pair, 2 plus or minus root 22 over 2, and then 5 plus or minus root 22 over 2. If I have to say it one more time, my tongue's going to get twisted. So, solving a system, set the x parts, the x expressions equal to each other, solve for the x's, and then plug that back in and get the y values. And we wrote our answer as a coordinate pair. I wouldn't, unless it said to do this on a test or quiz, I wouldn't expect to see you write like this. But if it says write your answer as an ordered pair, then you would have to write it this way. All right, last example. Example 4. So the directions are determine the points of intersection by hand. Determine the points of intersection by hand. Well, what do you mean? I'm going to give you a really basic graph. So let's draw a really basic graph. You don't have to do any tick marks. I just want a parabola and a line that looks like that. And we're going to determine those intersection points by hand. And you could do that in a calculator if you had second trace intersect. But you aren't always going to have a calculator in pre-calc or calculus, so we're going to do this by hand. So the equation for the parabola, this parabola, is actually just y equals 3x squared. The equation for the line is y equals x plus 2. So what are those two intersection points? Okay, this is almost the exact same question we just did. If you have this equation and you want to know where they intersect, that just means when are these two equations equal to each other. So again, all we have to do is set these equal to each other, and we can figure out the intersection points. So I'm going to say 3x squared equals x plus 2. If I can solve that, set them equal to each other and solve it, then that's the intersection points. Okay, so since this is a quadratic. It's got x squared. We need to get everything to one side and 0 on the other side. Then we can get our answers. So subtract the x, subtract the 2, move those over. So 3x squared minus x minus 2 equals 0. This one should be easier to get answers from. In fact, this one factors nicely. So, let's take a look. 3x squared. Only two factors that work for that are 3x and x. So those will go here. 3x and x. And then negative 2, well, you can only come up with 2 or 1. But since that's a negative 1 right there, why don't I put the negative 1 here and get negative 3, and then the plus 2 here. And I'll get negative 3 plus 2. That'll give me my negative x in the middle. So that actually factors nicely. And then you can solve it pretty easily too, right? So solve each one of these terms. Since it's that times that equals 0, solve each one. So for this one, x equals negative 2/3, because you subtract 2, divide by 3. This one is just x equals 1. But that does not tell us what y equals. So I'm going to take these values and plug them back into the easiest equation I can find, that one, for x. So y equals x plus 2. And again, I just left the x blank because I'm going to have to do this twice. I'm going to plug in these values and say what the y values were for these ordered pairs, because there's 2 points here. So I'm just going to plug in negative 2/3 for one of them and 1 for the other one. So negative 2/3 plus 2, well, if I'm going to add to a fraction, 2 I could write that as 6 over 3, right? Multiply it by 3 over 3, that's 6 over 3. So negative 2/3 plus 6 over 3, that's just 4 over 3. And then 1 plus 2 is 3. So now we actually know what those ordered pairs are. So these we should probably write as ordered pairs because it says the points of intersection. So my solution here, what are those points? When I plugged in 1, I got the 3, so that's 1 comma 3. And when I plugged in the negative 2/3, that's when I got the 4/3 out, so that's negative 2/3 comma 4/3. Alright, that's all for these notes. I'll see you in class.